I'm good.
You good? All right. Sure? You're looking like you're about ready for a nap.
Yeah.
All right. So the theme is what we've been on for the last several days. We're playing with the idea of linear relationships. What's that?
What number on the homework?
Oh, we'll get there in a minute. Yeah, I think we're going to do 10 in just a minute. But I'll show you once we get to that. But I just want to review a couple of things. So linear relationships, there's a few different ways to think about it. One way is on a graph, points line up. So once we have a set of points that line up, with a computer or by hand, we can connect those dots and then try and find an equation for that. So the most common way of looking at linear equations is to have something like this. Y equals some number times x plus some other number b. And a couple of things to consider here. The variables here are the x and y. X and y are the variables. They're the things that change. So usually the horizontal axis is x. And the vertical axis is y. Some other words we use when we're talking about these. Is the horizontal variable here is usually called the independent variable, sorry, independent. Because usually we pick a number for x, plug it in, and figure out what y is. So the y value depends on what the x is. So the vertical variable, the y, that's called the dependent variable. Because the way we have this formula written, it's designed to plug in x to figure out what y is. So in this case, each y value depends on a certain x value. That's why we call the y the dependent variable when we write the equation this way. Usually the independent variable is something like time. Like in the problem we looked at the other day with the number of healthcare workers in the US, that depends on the year that we look. And typically because the population's growing, there's more healthcare workers each year. So time is independent, but the number of workers depends on the year that we look at. That kind of makes sense? Independent versus dependent. All right, so we got two things here. We have graphically points line up. In terms of equations, the equation is going to look something like this. We may use different letters for x and y. Could be time, T for time, could be like H for healthcare workers instead of y. So a little more about that equation. The M and the B, they're special. So the M is always the slope. That's the idea of rise over run. Change in the dependent variable over change in the independent variable. And so we call that the rate of change. It's a rate because it's a fraction, and the numerator is some kind of change, like you rise, the denominator is a different kind of change in the run. And that's really the most important part of this, because not everything changes at the same rate. So in a car, if you treat the brake gently, you slow down, and you're just sitting there calm, versus slamming on the brakes, and you fly forward. Okay. If you fly forward like that, that means you're not slowing down at a constant rate. So you can kind of feel that thing. The B, the other number up there, that's just the starting point. Usually called the Y-intercept. Just where the vertical axis for Y meets your line, wherever they intersect. So we've got, looking at a graph, if the points line up, looking at an equation, it's got to look something like this right here. And the other thing we've looked at is we've looked at tables of numbers. And there's a few examples of that in your homework. Today. So is this table of numbers represent a linear relationship with X and Y, and how do I figure that out? I'm going to nod from Jenna. Anyone else think it's linear? Okay, so if it's linear, it's going to have a constant rate of change, a constant slope. Now notice the X values are jumping by 1 each time, and the Y values are jumping by what? 3. And as long as the X and Y's jump by the same amount, that's one way to tell if it's linear. Right? But it won't always work out that way at direct inspection. So for example, suppose we had the following table: 0, 5, 3, 14, 6, 23. And maybe 829. Is this table linear? Maybe, maybe not. So here's the harder part. The trick here is to pick a pair of points. And if there's a lot of points, it's really hard to tell. But these two jump by 3 on that side. What do we jump on the other side? 9. Now, just for fun, let's pick a different pair of points, and we're not going to pick the next two. Let's compare the first point to the last point. What's that changing by? 8 here, and about the other side? 24. Okay. So, how many times does 3 go into 9? 3 times. How many times does 8 go into 24? 3 times. Okay. So when I compare this number to this number, that's my run. On this side, when I compare two numbers, that's my rise. So is the rise of a run the same for both sets of points? Isn't it 3 both times? Yeah. So what we'd expect to see, provided that this point behaves right there. We don't know about that one yet. But these 3 points are going to line up because they have the same slope. They have the same rise over run once we simplify that fraction. So we have 3 different ways to look at lines: graphs, tables, and equations. All right. So let's take a picture and combine all that stuff together. So I think, what did I have isolated? Number 10 maybe, and 3, 4. Nope, not there. Not there, not, oh, here we go. Number 11. Okay, so remind me about that in a minute, Emily. 3-3 homework number 11. So I'm given a picture and I'm asked to find an equation to go with it. So let me get a screenshot of that. See what we can do with it. So the trick is to look at this picture and see if we can identify a few points on the graph. So mostly I'm looking to where it strikes a vertical and a horizontal line. Does it anywhere? Not really. Any guesses at what this point right here might be? The y value looks like it's -1. What's the x value there? 0. Yeah, so this right here looks like the point. So like if I build a table over here, it looks like I have the point 0, -1. And, you know, based on that, I'm guessing that point right there is probably -2, 1. Seem reasonable guess? Let's get one more point just for fun. How about maybe this one right here? Any guesses as to what point that might be? Looks like y is -5. What's x? 4. So I stated this 4, -5. So to come up with an equation for this line, switch colors, I'm trying to find something that looks like this. Y equals m times x plus b. What do we think b is here? The starting point is where it hits the y-axis. What's the y value there? Okay, that would be -1 right here, is where we think it hits. So I think the b is this -1 right there. For the slope, I have to pick a pair of points and find the rise and the run. So make a quick sketch of this on your paper. If you don't have paper, get some paper, please.
Right.
So the b is the number, the y value at the point where it hits the y-axis.
Yeah, so if you're at your y, if you at the other points, can you just put y?
X equals 0 is the y-intercept. If you plug in, because you're not going left or right, so if you pick x equals 0 and see where you end up, that's the y-intercept. But we don't have an equation to plug 0 into yet. All we have is a picture. So either based on this table or based on this picture, come up with a slope for me. What's the rise and the run? Write something down. Pick 2 points. How do you move to get from one point to the other? Probably won't write something down. Even if you're not sure, write something down anyway. It's better to try and be wrong than not try. Just watch. It's like me yesterday. I was watching this guy ski down this steep hill, and I'm like, yeah, I can do that. It didn't work out so nice for me. I didn't want to roll in the snow. I didn't practice enough. So it shouldn't matter which 2 points I pick. If I pick the first 2 points, say to get from this point right here, it looks like I'm going to go over 2, so that'd be my run. And then I'd have to drop down, looks like 2. So according to those 2 points, I think the slope is a drop of -2 and a run of +2. So I'm getting a slope of -1 from those 2 points when I clean it up.
Can you not choose from the x and y table for the 2 points?
You can do it from the table too. So I could do it over here. I'll stick with this color. So to get from this number to that number, I'm going to have to go up 2. To get from this number to that number, I'm going to have to drop 2. So rise is always from the y values. So according to the table there, I'm going up 2, and I'm going left 2 for the bottom. 2 over 2 is 1, positive over a negative is negative, so I still get the slope of -1. So we got to keep track of the signs as we do that. I'll do it 2 other ways just to try and help us get used to it some more. Oops. All right, so I'm going to do this one more time. So there's another version of slope if you read your worksheets. To find the rise, you have to subtract 2 y values. To find the run, you have to subtract 2 x values. So basically this says pick a first point. That's going to line up that way, and then pick a second point. So you can plug them in here. So I'm going to pick this point right here as my first point. So that point right there is what? -2, 1. So that's my x1, y1. And I'm going to go for that point we picked, where was it? Over here. This one's going to be my x2, y2. All that means is your second x value, your second y value. And that was what? 4 for x and -5 for y. Did I get that right? So according to this equation up here, if I want to do it that way, use the equation. And some people like equations better. I like charts and pictures. Then my second y value is -5, agreed? So here I would take, to get the slope, oops, okay, try again. Oh shit, sorry about that. Okay, 3rd time's the charm. There we go, I got a pen. You still with me, Elena? Okay. Make sure you don't fall asleep on me. So I've got -5 for the second y value, minus the first y value of 1, divided by the second x value, 4, minus, and here I got to be careful, that's a -2, so I'm going to put it in parentheses to be careful with it. So I can just plug right in there. Things to double check. Do I have y values in the numerator? Do I have x values in the denominator? And here's the third check. Do my points line up? Is 4, -5 really one of my points? If all of that stuff lines up, then this should work out. So what's -5 minus 1? -6 on a good day. And what's 4 minus -2? That would really be 4 plus 2, right? Which is 6. Negative over a positive is negative. 6 over 6 is 1. We get the same thing as before. Right? So there's lots of ways to do it. You're going to find a way that's comfortable for you. I prefer a picture or a table whenever possible. All right, so we found slope like 3 different ways here. Let's put it all together. Ultimately, we were asked for an equation for this problem. So let's go double check what we were asked. All right, we were asked to find the slope, and we're pretty sure the slope is what? Almost, not 1, but -1, yeah. And then the y-intercept, what is just b? That number b. We think that's also -1. And so, submit. Hooray, we get it right. Let's do a new one. Oop. If I look back at my slide here, looking at the picture, I think it hits right there at y equals -1. So that's my b. Yeah, and I think it's a different one for each time. So yeah, that's a different picture this time. All right, so let's do it one more time. So I'm going to clip this out of here, and then we're going to do it with some more interesting numbers. So these numbers aren't as much fun as bigger ones, according to you guys, right? Can you tell me you want to do it with bigger numbers? because it's more exciting? Oh, I'm sorry, I'm just messing with you. Okay, so take a look at that graph right there. See if you can identify a couple of points, one of which you want to be the y-intercept. And what I want you to do is write down what you think the equation for this line is, and then I'm going to test your equation. So we want to say y equals mx plus b. I need to know what is m here and what is b. So write something down, redraw a picture or make a table. You're going to find a method that's comfortable for you. You might want to recommend another point for me. Three zero. Okay. So here, there's my rise, there's my run. So let's see what I do there. I dropped 2, and I went 3 to the right. So I think the slope is going to be negative 2/3. And the y-intercept seems to be positive 2. So I'm thinking the equation is y equals negative 2/3 times x plus 2. Anybody else agree? Got a couple of nods. So that doesn't mean we're right because we agree. So here's where we're going to test it. The point I was thinking about picking was this one right here. That looks like the point 6, negative 2. So what I want you to do is plug 6 in for x and see if our equation gives us the right y value. Clean that up on paper or on your calculator. So what I'm going to do without a calculator, when I have to multiply fractions, I would make that as a 6/1. And then since I'm multiplying, I can clean it up a little first and say 3 goes into 6 twice. 2 times negative 2 is negative 4. Plus this other 2 gives me a negative 2. It checks. So I got it right. Sometimes checking it's as much work as doing it. But if it matters, we should check it. So on this one, on the online homework, all they wanted me to do is state what the slope was and state what the y-intercept was. So I would have typed in the negative 2/3 for m, and I would have typed in the 2 for b on that one. So it takes a little getting used to. One more, and then we're going to move on. Let's see, Emily mentioned, was it 9 that you mentioned?
Yeah. Are you just doing that?
Maybe. Why, do you have another one you want to look at?
I just had trouble with 4 and 5, but they're longer. So
In this one right here?
Yeah.
Okay.
You don't have
That's okay, we can do it.
I figured out
Yeah, so just looking at this right here, the slope is always the number that's multiplied by x, so the slope here would just be 2. The y-intercept, it depends on whether they want that as a point or as just the y value. And notice here it says make sure the y-intercept is written as an ordered pair. So that means they want it in parentheses. So what point does the y-intercept happen at? What's the x value at the y-intercept? 0, because we haven't gone left or right. We're on the y-axis. And then I could go comma -6. Yeah, so just based on this instruction right here, they didn't want just -6. They wanted me to enter it as a point. And some people, when they say y-intercept, they mean just the y value. Other people, they want the whole point. Usually, I want the whole point. All right, let's back up. Let's see, which looks more exciting, 4 or 5? I'm going to bump this into a new window. Let's see, how do I do that? Here, maybe. That's better. Number 4, number of swim days, cost of season pass, cost of paying per day. That one looks sufficiently complicated. And intravenous drip. I like this one too. All right, anybody want to vote 4 or 5? We can do one of them. The drip?
Yeah.
Oh, good. That's my favorite one here. All right, so doctors use an intravenous drip to deliver medications, and they usually try to set the flow so it's constant rate. Okay, so here they're trying to set it up so that every minute, 2 milliliters is going to come through that IV. And they're starting with 1,000 milliliters. So we want to write an equation using F for fluid. So that's the amount of liquid that we have. And T is every minute. And that's a good thing because here they talk about milliliters of fluid and here they talk about minutes. So the information that's given is matching how they want us to write it up. Okay, so I'm going to steal part of this for my sheets. Screenshot it. All right, close enough. So which number here looks like a rate of change?
2.5.
Yeah. So the slope, m, is 2.5. Now I'm going to write it as an actual fraction. 2.5 over 1. Okay. And then the numerator, let's see, is that milliliters or minutes for the numerator? Milliliters or minutes for the numerator? What do you think? What's per mean? Divide. So milliliters per minute means milliliters divided by minute. So this must be milliliters, and this must be minutes. So let's see if that makes sense. Which kind of numbers go on the top? The y values, the dependent numbers, or the x values, the independent numbers in the numerator? So the dependents, the y, go on the top. So always the y, vertical change goes in the top. So these numbers right here, this is our vertical change. That's like our y values. And these down here are horizontal change. Those are like our x values down there. Now here, instead of y equals mx plus b, they want us to use f for the fluid. And the fluid depends on the time, so that's going to be m times t plus b. So every once in a while, we're going to throw in different variables to match whatever situation we're talking about. And so for our formula right here, we think that the fluid is going to be, let's see, are we losing fluid or gaining fluid from the IV machine? From the IV machine.
Oh.
Yeah, so they're talking about the IV bag here is what we're focusing on. So we're losing 2.5 milliliters every minute times the time. So this is my m times x. So instead of an x, I'm throwing a t. And b is always the starting point. What are we starting at? That's the 1,000, yeah, plus 1,000. So that would be the formula we want. Now I did over 1, that's not necessary. I'm just reminding you slope always is a fraction, even if we don't write it that way. So technically, the way I would write it is without the 1 in the denominator. And I would just say it's negative 2.5 times t plus 1,000. And so that's the equation that guides this situation. We're losing 2.5 milliliters per minute from the IV bag. We started at 1,000. Let's see, where is that screen? Over here, maybe? Yeah. So I'm going to write it as F. And notice it says write an algebraic equation. Anytime it says equation means there's got to be an equal sign in there. So negative 2.5. And you can either put the t or you can do times t, whatever makes you happy. I'll accept it either way. All right, and then it shows me what it looks like. It says syntax is okay. It means I typed it right. Doesn't mean the answer's right. Is this linear? Yeah, it's linear. Why is it linear? Same rate of change. Beautiful. Oops. Okay, same rate of change is a sufficient answer there. Okay, how long will it take to use all of the saline? Ooh, this one's a little more fun. Go back to the drawing board on this one. Yeah, we want the fluid equal to 0, and then we solve. Oops, wrong direction. All right, so we have F equals negative 2.5 T plus 1,000. And like Emily said, that means we want no fluid. How much time? And do your best to solve that. We'll see if we can match. Um, 400 minutes, maybe? Yeah? Yeah, so then now we got to translate that in hours. So there's 60. How many times does 60 go into that? 6.6? Okay, so the 0.6 is a problem. So I'm going to do it a little different. I'm going to take 60 into 400 with long division because I want to figure out how many minutes are left over. So 6 goes into 40. What, 6 times 6 is 36? Okay. So if I take 6 times, and we already have a clue from the calculator, right? The calculator said 6.6, didn't it? So 6 times 36, 6 times 6 is 36, put a 0 on that. Oops, too many zeros. Hurry away. Sorry about that. And then we subtract how many minutes are left over? 40, so we have 6 hours, 40 minutes. Another way to do that with the calculator, for those of you who really aren't that fond of long division as me, when we took 400 and divided by 60, we got 6, was it exactly 6.6 or was it 6.66? It was repeating, right? Yeah. Okay, so that repeating part's a problem, but this right here guarantees us 6 hours. The question is what is this right here? So what I would do next there, how did we get into this situation with the 0.6? We divided by 60, right? So to undo it, we multiply by 60. So take that 0.666 and multiply it by 60 and see what you get. So on the calculator, what you could do is everybody on your calculator, let's see, I'll do it with you. If I can get my calculator to work today. Let's try Firefox calculator. Close. I'll show you how to make it even better. Let's go Google so I can get the calculator out. Okay, so let me blow it up just a touch more. So starting with my 400 divided by 60. Oh, it's not working here either. Oh, I'm cursed. All right. I'll just explain it without a calculator since I can't get a calculator to work. New page. So on the calculator, you start with your 400 over 60. That gives you that 6.666. And eventually, your calculator is going to probably throw a 7 at the end. Right? So what you do next is on your calculator, go minus 6. Then what it'll say is, oh, you just want the 0.666, blah, 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 7. Guess what I'm going to do next to that? Multiply that by 60. Then you don't have to worry about rounding error, and it should spit out exactly 40. So give it a shot if you haven't already. That should work on 95% of calculators in the world. Maybe 96. It work?
Am I supposed to get 40?
Yeah.
Yep.
Oh, I'm sorry, I should have wrote that down. That should lead us to 40. Yeah, I said it, but I didn't write it. All right, well, that was fun and exciting. So we did a whole bunch of review, which is fine. We are behind the calendar that I posted, and that's fine too. I will adjust it. I'm going to hand out the 3-4 worksheet right now, and just you already have one, and just talk about it a little bit, and then we'll work on it for real next class. Hopefully this gives you guys a chance to catch up if you fell behind in any way, or if you were still perplexed by the lines and rates of change. It does take some getting used to. So section 4 is more of the same stuff. So let me bring up the worksheet and make some comments. We are going to do another spreadsheet. Get better at using spreadsheets. So our goals are still to talk about that constant rate of change. Sometimes it's increasing, sometimes it's decreasing. And the scenario that we're going to start with is a weight loss program. So we got a bunch of different people that started off at a particular weight, and they went on a diet together. And some people lost weight, some people gained weight, some people kind of maintained a steady state. All kinds of stuff happens. Okay. So let's look at Jonas for a second. Does he have a positive rate of change or a negative rate of change? Did he increase or decrease? Yeah, he's increasing. That's what we call a positive rate of change. How about Marcel? Decreasing or negative rate of change is what we call that one. What about Carrie? Stayed the same. So what does that mean for the slope, do you think, if they stayed the same? 0, yeah, there's no rise. Yeah, so there's a 0 rate of change there. Yeah. So we're going to play around with this. We're going to try and come up with some models like we did with those previous problems that we worked on. Just we have slightly bigger numbers. Okay. Starting points are our y-intercepts. Those are our b values. And then we have to figure out slopes for each person here. Okay. And then we're going to move along from that. So here they kind of elaborate more on the stuff I did today in the second page. So tomorrow, and then this problem is a little more complicated. It's going to take all of us together working on this one. We're going to take a look at milk consumption in the United States versus soft drink consumption. What do you think's happened over the last like 60 years? Soda has become more popular. Milk has become less popular. So the amount of milk we consume has been on the decline. The amount of soft drinks we take in has been dropping. Now, these are going to be bigger numbers that we have to work with, so the spreadsheet's going to be super helpful. So we're going to analyze that problem together in class. So what I'd like you to try and do is for homework tonight, see if you can work through the first page, and then we'll sit down together and I'll have you compare with your neighbors right away on the first page, and then we'll jump in soon after that on the second page together, or the third page, sorry, the soft drink versus milk problem. All right, that's it for today. go forward and do good math and other good stuff, and we'll reconvene tomorrow. Got a question?
It's
Sure.
just part D that I'm having trouble with.
Part D on which problem?
The same one.
The one we were just on?
Yeah.
Okay, let me take a look.
Thank you.
All right, so I've got that on one of these pages. Did I make it go away? Oh, here it is. All right, let me zoom out just a touch. So we got our 6 hours and 40 minutes. Okay, which of the following can be used to describe the points that we found? Oh, well, here's my best way to deal with points, graph them. So new page.
Is this still for that same?
This is, what's that?
Is this for that same problem?
This is that same problem, the IV drip. Yeah, if you got that, don't worry about it. So let's see. This is our fluid, our Y. And this is our time in minutes. And we started off in the beginning with 1,000. So 1,000 milliliters is way up here somewhere, right? And then what did we just figure out? It took 6 hours to do what? To get zero fluid. So zero is here. So the 6 hours is somewhere over here. That's our 400 minutes. So there's one point. Here's the other point. So we just found 2 points on this line. So now the question they're asking in that last one, what does that point right there represent? Is it the slope? Is it the vertical intercept? Is it the horizontal intercept? Horizontal, so vertical means up and down. So right now I am vertical.
Okay, so if you were like.
Tonight after 9 o'clock, I hope to be horizontal. Okay? Yeah, so horizontal means laying flat, vertical means upright.
So then are you the horizontal?
Yeah, we found the horizontal one, yeah. Yeah. So that's what that last number means. We found the horizontal intercept there.
Thank you for doing that. I'm sorry it took so much time.
No, it's fine.
Do it go crazy.
Yeah, and don't forget, you guys have that message your instructor button. So if it's Saturday and you know, oh man, I really gotta wait till Monday to answer, hit that. I check my email a few times each weekend. So hit that message your instructor, and up will pop a copy of the problem. And it'll also give me a link to anything you typed. So I can go take a look. And so you can send me a question, I can look at what you typed, I can read the problem. And either I'll get back to you or I'll say, yeah, we better do that one in class.
Okay.
Yeah.